So hello everyone. In this video we'll be looking into the locking mechanism with threads. So we'll be discussing what exactly do you understand by the concept of thread synchronization. So now, as we have already seen that the concept of multi-threading involves multiple threads which are executing in parallel. So obviously, when multiple threads are executing in parallel, are executing concurrently, so we might have certain synchronization problem. Like for example, what could happen that if I write one program, maybe I write one program void main do a transaction from A to B, and A and B are two account types. So A is one account, right, and B is another account. So I might want to perform a transaction from account A to account B. Okay, and I use one thread. So let's say thread one is there which is executing this piece of functionality. Now simultaneously what could happen, another thread comes, thread 2, and it also start executing the same piece of code. Now let's suppose the transaction of thread 1 is in middle, and at that particular point only thread 2 comes and start executing the same piece of code. So this would result in inconsistent output. The output will be inconsistent. So let's say if I have more broader scope, like I want to make a transaction from account A to account B, and then again from account B to account A, and then two threads starts executing this piece of code. So let's say thread 1 is at this particular point and thread 2 is at this particular point. So let's say thread 2 1 is making a transaction from account B to account A, but simultaneously thread 2 comes and makes another transaction from account A to account B. In this case again we'll have an inconsistent output, and the ultimate balance reflected on both the account may be invalid. So let's say when thread 1 is executing this particular statement, what could have happened, I am making a transaction from account B to account A, and I am taking all my money from account B to account A, and I'm pouring all my money to account A. And let's say if the thread 2 starts executing in the middle way, what thread 2 could do, thread 2 would also take all the amount from account A and would put it in account B. So obviously this would result in inconsistent output if we are executing both the threads in parallel. So to avoid this, we use the concept of thread synchronization with locking mechanism. So before going into this process, let's see one important concept, which is critical section. So critical section, you might hear this term a lot of time. It is a segment of a program that is very critical. It is a segment of the program which is whose execution is very critical, very crucial, and at a given point only one thread could execute this critical section. So this is the main concept under the critical section, that it is a very important piece of code, and at one particular time only one thread could execute this particular segment of the program. So let's say in this particular concept I might say that this is the critical section, okay, of my program. In this particular concept I would say that this is again a critical section of my program. So these two are the critical sections because we don't want any other thread to come up and start executing it. So critical section is a very important concept in your operating system, and in order to have consistent output we use the concept of locking which is known as mutex. So mutex is a concept which we use to achieve mutual exclusion when we talk about threads. So when we talk about the concept of threads, we use mutual exclusion. So what mutual exclusion does? Mutual exclusion is a locking mechanism firstly. So mutual exclusion gives the thread exclusive access to the critical section in such a way that no other uh, thread could again execute the same piece of code. So it is mutual exclusion is basically a congruency control property. Okay, and it helps in avoiding any synchronization problem that we might face while executing the program. So it is a property of we can use it for thread synchronization, we can use it for process synchronization, and it basically states that no two processes can exit in the critical section at any given point of time. So this means no two process can again exit in the critical section. Exist, this is not exit, this is exist, or let's say enter the critical section at any given point of time. Okay, because we want mutually exclusive access of that area for any particular thread. This is what the meaning of mutual exclusion is. So when we talk about the concept of mutual exclusion, another very important concept comes, which we'll be looking at, are the problems or how to basically handle thread synchronization. So before let's say having a look into the concept of the mutual exclusion, let's first look at some example which will clearly tell us that do you understand by the thread synchronization problems. So what are the synchronization problems that you face when we talk about the concept of thread? So thread synchronization problem. So let's say I take one example. I declare one thread, p thread underscore t tid 2. So these are the two global variables which I am declaring, and I write one function void try this. Inside this I declare one counter equal to counter plus 1. Then maybe I start writing the function. Just a second. Yes, so I now here write any for loop, maybe a loop for loop, and I write printf the job has finished, and before this I write one line which says, let me change the color, printf job started, right? And then again so let's say I have this function with me, and I write again int main So this is one function whose objective is first to create two threads. So two threads would be created. I am now simply joining those two threads. Okay, so this is one program which uses the concept of the thread synchronization problem. So what the problem here is, I have I've made two threads. So you can see the create function. The create function is doing what? It is creating two threads. How is it creating two threads? You can see the I value is initialized to 0 here, right? Then I use this a while loop till I is less than 2, which means the value of I would be 0 and 1. When the value of I is 2, the program it will come out of the while loop. So for 0 and 1, two threads will be created here, one with TID 0 and one with TID 1, right? These two threads would be created, and what I will be doing, then I will be joining both of them. So you can see here TID 0, TID 1, both the threads are joined. Now when you run the above program, you will get the output as job 1 has started, then job 2 has started, then job 2 has finished, and then again job 2 has finished. So you are getting this output when you run this program. So when you are running this program, what exactly happens is, you basically see that a value of counter and is defined here, which is a global variable. So as soon as this is printed, job 1 has started, and then some loop executes. Then after, as soon as job 1 has started, it should print job 1 has finished. But you can see job 1 has finished is no longer there. Instead, it has simultaneously started the second job, which means the second thread, it has started before executing, before the execution of the before the execution of the first thread completes. Then even then also second thread has started. So this results in the inconsistent behavior on the and the inconsistent value of the variable counter here. So the counter variable becomes inconsistent. So if we take the above assumption, this is true, then the value of counter variable got incremented again before job 1 has got finished. So ideally, what should be the output? Ideally the counter value should be incremented first, then it should print job 1 has started. Okay, and the value of 1 comes from this counter only, because the value of counter is 1, so it prints job 1 has started, then it prints job 1 has finished, this. And then again value of counter should be incremented to 2, and it should give me job 2 has started and job 2 has finished. So this should be the output. Okay, but you can see I get the output job 1 has started, and as soon as again I got the output job 2 has started. So this is because the value of the counter variable, it got incremented again before the printing of this line job 1 has finished. So when job 1 actually got finished, then the wrong value of counter produced the log job 2 has finished, and then again followed by the value job 2 has finished, and vice versa. It obviously depends on the scheduler. So we see that it's not the repetitive log but the wrong value of counter variable that is the problem. So the problem is the wrong value of this counter variable here. Now how can we solve this problem? So idea is how to solve this particular problem. So in order to solve it, we'll be using the mutex log. So mutex is what? It is a log that we set before using a shared resource. Okay, and it is obviously released after using it. So it is released after using the resource. And when the lock is set, no other thread can access the locked region of the code, which we see. So even if in the previous example, if I talk about, even if we see that thread 2 is scheduled while thread 1 has not completed its execution, the code should be logged by thread 1 using mutex, and thread 2 should not be able to access this particular region. So ideally thread 2 should not access this particular region, because as soon as thread 1 starts executing it, it should be locked. So how again? So when we talk about mutex, there are some important functions which we should know. First is the init function, that is the initializing the mutex. So first what you are doing, you are initializing the mutex variable. Now this function, it does what? It basically creates a mutex with specific attributes. So the syntax is something like this. So these are the attributes, two attributes. So if successful, this function returns 0, and if unsuccessful, this function returns -1. Second function here is the lock function, when you actually lock your particular segment of code. So this does what? It locks a mutex object. So as you lock the mutex object, the syntax goes like this: int pthread underscore mutex underscore lock pthread mutex underscore 3 pointer mutex. So the thread has locked a mutex, which means it has become its current owner, and it remains the owner until the same thread has unlocked it. So again the same thread locks the critical section, and then again it unlocks the particular critical section. And when the mutex has the attribute of recursive, the use of the lock may be different in that particular case. So again same, if this function is successful, it returns 0. If it's unsuccessful, it returns the value -1. And the mutex can be unlocked and destroyed by calling the following two functions. So what are those functions? Third one, that is the unlock. So this does what? This releases the object. So this releases the mutex object. You use the unlock function. If one or more threads are waiting to lock the mutex, this function causes one of those threads to return from the lock function with the mutex object acquired. And if no threads are waiting for the mutex unlocks with no current owner, and the same value is returned, value 0 if it's successful and value -1 if it's unsuccessful. These two values are same returned in this case. Now next, fourth is the destroy function. So destroy function, what it does, it finally deletes the mutex object which identifies a mutex. So again, mutex are used to protect the shared resource, and it is set to an invalid value which can be reinitialized by using the init function. So we have four functions here. What the fourth function does: first we are initializing the mutex, then we are locking the critical section with the help of the mutex, so which is known as the mutex object. Then we are unlocking it, we are releasing the mutex object, and finally we are destroying the mutex object, we are destroying it. Now if I see this previous program, how can I change the previous program using the mutex mechanism and ensure the thread synchronization? So again we'll be using all these four functions which would help me to achieve the thread synchronization. So now we'll see thread synchronization using mutex. Again important concept. So again what I do, I now write again the program int counter, let me this time write neatly, then I create the thread, so these are the three global variables which I declare. Then I write one function which will be called by the threads that I will be creating. Inside this function, first I create the mutex lock. This is the function. Now next I write the same piece of code, unsigned lock I equal to 0, counter equal to counter plus 1, printf job has started, and I print the value of counter here. Here it should be, so since I am printing the value of the counter, so obviously here should be, I should write %d here. Then a for loop which is actually doing nothing. I again write printf job %d has finished the value of counter here. Then I write pthread underscore mutex underscore unlock. So this is the complete function which will be executed by the threads. Now I write the main function int main. Inside main I define two variables. I write the if condition, So this particular statement does what? It sees whether the mutex has been initialized correctly or not. So if not, it throws the error. Otherwise, it simply goes and initializes the mutex. And similarly, I use the pthread create function to create the thread. I again check if error is not equal to 0. I write printf threads cannot be created and I throw the error here, and I increment the value of I so that 2 threads gets created. Same thing I'll be using with the first thread here, and then I write pthread underscore mutex underscore destroy and will pass the log here. Now this is the complete program which talks about the thread synchronization using mutex. We saw the 4 functions that talks about acquiring lock from the that talks about how locking can be used with threads. We saw the init. First is the initializing the mutex, the init function, then the lock function, then we saw the unlock, and finally the destroy functions. So these are the 4 functions which we saw. Now the concept is, when I talk about the thread synchronization with the mutex, I will be using all the 4 functions here in this case. So let me just highlight it. First one, third one, and the fourth one. So these are the 4 functions which I am using when I talk about thread synchronization using mutex. So as per this logic, what I do, I start with the main function here. Inside the main function, what I do, I have uh, initialized the mutex first, as already explained that mutex would be initialized first. As soon as the mutex is initialized, I check whether it is initialized properly or not. If it's not initialized properly, I will print the, I'll throw an error. Okay. Otherwise, if everything goes well, I am assuming that the mutex is initialized. Then I start with the while loop. The while loop says that let's start creating 2 threads, tid0, tid1, because I is less than 2. So this creates 2 threads. Again, I check whether the thread creation is successful or not. If it's not successful, the error, this message is thrown. Otherwise, the thread is successfully created, obviously. Then I join both the threads. Now what happens is, and both the threads will be executing this try this function. So this function is the function which both the threads would be executed. Now when they are joined, this particular function is started. Inside it, what I do, I lock the mutex object by passing the parameter lock. Okay, so this is the lock here, which I have defined as the global variable here. So this is the global variable lock. I use the lock function, pass this particular address, and I use I first lock my mutex. So in this particular case, this is what the critical section of this particular program. So this is the critical section, and no two threads are allowed to run or enter into this critical section simultaneously. Now only one thread would be initialized here, would be executing this particular piece of code. After it has executed the critical section, the mutex will be unlocked. Okay, and as soon as it is unlocked, the second thread gets the opportunity again to access the same piece of code, the same part of the critical section. So the second thread also executes it, then again the second lock is unlocked, and finally you get the output as job 1 has started, job 1 has finished, job 2 has started, and job 2 has finished. So this is the output. Now you see the order here. Job 1 has started, job 1 has finished, which means first the value of the counter is incremented. Okay, then it is started, it is finished. In the meanwhile, the value, when you are printing the value of counter, no other thread is updating the value of counter here. So the value of counter remains 1 only. As soon as the job 1 is finished, this lock is unlocked. Now the second thread comes, it then executes this particular line, and the value of counter is incremented and goes to 2. In that particular case, it will give me the output as job 2 has started, job 2 has finished, and again it will be unlocked. So a mutex is initialized in the beginning of the main function. In this particular case, the same mutex is logged in the try this function while using the shared resource counter. So here counter is the shared resource. So we are using the lock. We always use lock on the shared resources, which is pretty much obvious, because since the resource is shared, so obviously multiple process might want to use it. So here the counter variable is a shared variable in this case. Then at the end of the function try this, the same mutex is unlocked. So you see in this particular case, the mutex is unlocked, and the most important, first the mutex is initialized, then the mutex is locked, it is unlocked. When everything is done, we come back again to this last line of the main functions, which says destroy the mutex. Now so now the mutex is destroyed. So these four functions, the start time, these four functions basically helps you to achieve the thread synchronization using mutex. Now here the output is consistent, whereas previously if you see the example, the output was not consistent, the output was inconsistent in this particular case, because before printing job 1 has finished, the value of the variable counter was accessed by second thread, and it got incremented. So the value of 1 got incremented to 2, and it printed job 2 has started, job 2 has finished, and then again job 2 has finished again. So this was the problem in this particular case. So this was all about the locking mechanism with threads. So the concept here is the thread synchronization is basically achieved with the help of mutual exclusion log, which says that no two programs, no two process can enter the critical section at the same time in a given part of a code. And this is the main objective of this particular lecture. Now if you see the assignment here. The assignment also uses the same concept. It says that imagine a scenario. So the question is a little bit twisted. Imagine a scenario where a bank is trying to process two transactions simultaneously using two separate threads. The bank uses two locks to ensure that no two transactions access the same account at the same time. However, there is a bug. So what happens? Thread 1 is trying to transfer money from account A to B, while thread 2 is also transferring the same money from account B to A. Both threads start executing at the same time and both try to acquire the locks in different order. So thread 1, what is the order? Thread 1 acquires lock 1 to access the account lock A and then tries to acquire lock 2 to access account B. However, thread 2 has already acquired lock 2 to access account B and is waiting to acquire lock 1 to access account A. As a result, both threads are waiting for the another to release the lock, and this also results in a situation which is known as deadlock, where all the processes are waiting for the other process to release their resource so that they can process with their own independent execution. This is the concept of deadlock. So when you implement this program, you will see that we have used the mutex lock here. Okay, so mutex lock is being used, and then so let's say first mutex lock is there, it is on block 1. So thread 1 has acquired lock 1. Okay, and then again you see thread 1, the same thread is also trying to acquire lock 2, and it has acquired lock 2. So you see thread 1 has acquired lock 1 also and lock 2 also. Now the second function, which is of thread 2, it also does the same. So it acquires lock 2 first and then it tries to acquire lock 1. Now when they are joined and when this program is run, it results in the deadlock output. So why? Because thread 1 has acquired lock 1 and lock 2, and thread 2 has also acquired both the lock. So obviously uh, this results in a situation of deadlock, where again this is a case where again no error checking is being performed, and uh, the locking should be in such a way that the deadlock should not be there. So ideally what should have happened, that as soon as you acquire lock, you should also release it, because you are only acquiring, you are not releasing it. So in order to achieve that, the second program, what it does, it uses the concept of unlocking to release the lock. So what it does, as soon as you are getting the lock, you are releasing it. Whereas, so you can say in this particular case, I got the first lock, I got the second lock, and then I unlock it. Whereas in the second program, if you see, I get the first lock, I acquire the lock, I do some work, and then I release it. Similarly, so the same process is executed by both the thread. So this ensures a fair execution, that you have acquired the log, you are releasing it, and that way there is no problem of a deadlock that is being happened. So this is how you have first created a deadlock situation, then you have used mutex functions properly in order to release the lock. And you can see again we have used all the four functions here: mutex init, mutex lock, mutex unlock, and finally mutex destroy, to have a fair execution of all these four functions. Whereas in the first case, what I did, I only had the mutex initializer. I have just initialized it, I have logged it, and I have unlocked it. I have not destroyed it. and that's why the second thread is also able to take over that particular program, because I haven't destroyed it. So the order is, you have to first initialize the thread, right? Then after initializing the thread, you have to lock it, then you have to unlock it, and eventually you have to destroy it. This is the final four set of execution, the complete flow of execution when we talk about the locking mechanism in C. So okay, this was all about how the deadlocks are, you can simulate a deadlock, how you can avoid the deadlock, how you can achieve synchronization, proper synchronization in threads. So this was all about this concept. So thank you everyone.